Previously, we discussed discovering ML use cases, and here I will talk about how to be successful at machine learning. Whenever we meet a customer and talk to them about potentially using machine learning, the very first problems they suggest are often the problems for which they're already using data to carry out predictive analytics. Many conventional business forecasting problems can be done with machine learning. For example, you can use machine learning to forecast sales, forecast demand, estimate customer lifetime value, or predict how often a coupon will get used. But is machine learning the best approach for these problems? The answer is, of course, it depends. So let's talk about what it depends on. Let's say you run a bicycle rental service, and because traffic patterns don't quite balance out, you want to know how to deploy the personnel who move bikes around to restock certain rental stations. Let's also say that rentals that are less than 10 minutes long aren't profitable to you. So this leads to an interesting business question. Under what conditions is it worth restocking a bicycle rental station? One way of answering this question is to use historical data and compute the fraction of rides that are less than 10 minutes. So first, you compute the overall fraction of rides that are less than 10 minutes, and you can do this with a simple SQL query. And when you do, you see that the fraction is small, about 15%. On this diagram, the blue dots are longer rides that are profitable, and the red dots are short rides that aren't. 85% of rides are profitable. So we should always restock, right? Of course not. Information this coarse doesn't help you make any business decisions. You really need to know things at a more fine-grained level. The question is not whether to restock or not, but when is it worth restocking? It cannot be the case that restocking will always be profitable. So you refine the question to be, what is the fraction of unprofitable rides by day of the week? And so you change your query to aggregate by day of week, and now your data look like this. You discover that weekday rides are significantly less profitable. They have lots of red dots. Weekend rides, though, are very profitable. So you tell your boss, pay the stockers overtime. We really need to make sure that the bicycle racks are kept stocked on weekends. But your boss isn't going to accept that. I'm not paying overtime to stock every station, she tells you. Come back and tell me which stations I should keep in stock on weekends. So you repeat your analysis, only this time you aggregate by both day of week and station. And now you look at your data and you look at how many rides for each of these bins. And you bring the report to your boss and you tell her, we should pay overtime at these stations, but not these. But she still doesn't accept that. She asks for even more granularity. And you can imagine repeating this process indefinitely. There are many characteristics for each ride after all, whether it's raining that day, whether a station is near a subway station or not, things like that. So even though rides have many characteristics, there's a limit to how fine-grained your analytics can go, because with every new dimension you aggregate on, you reduce the number of rentals per bin. Thinking back, there were already bins that were nearly empty after splitting by day of week and station. Fundamentally, this is where machine learning can help. Machine learning can help you predict the value for things that haven't happened before, such as rentals on a particular day of the week at a particular station based on similar stations. This leads to a simple test. If the number of features is small, try using analytics. If the number of features is large, use machine learning. AirAsia Group is a pioneer of low-cost air travel in Asia. It serves more than 100 destinations for hubs in Malaysia, Thailand, Indonesia, and a growing list of other countries. AirAsia is using machine learning to refine pricing, increase revenue, and improve customer experience. In 2018, AirAsia established a groundwork to use machine learning to optimize pricing for a range of services. Our team was fortunate enough to work with them, and I met some of them in Singapore. They use Google Cloud machine learning engine to sort and predict demand for ancillary services such as baggage, seats, and meals. For a low-cost carrier, a good stream of revenue comes from these ancillary services. So it's very important to accurately predict demand for these services and be prepared. For example, to make sure that a meal is in stock when a customer wants to purchase it. There are lots of factors that go into being able to successfully predict the number of vegetarian meals that AirAsia needs to stock. It's not as simple as knowing the size of the plane. Planes to and from India, for example, will tend to have a lot more vegetarians. But not just that, the time of day probably matters, as does which flight's connected to this one. After all, you can't just stop the plane and pick up a vegetarian meal. And the more factors there are that you have to balance, the more useful machine learning becomes.